Three small conducting spheres carrying a charge plus Q, minus Q and plus Q are located at the vertices of an equilateral triangle ABC, situated on a frictionless horizontal surface as shown in the figure. Spheres at B and C are fixed and sphere at A is free to move. The possible path of sphere at A is best represented by, there are three charges. These two charges are not moving, minus Q plus Q, and this one is a movable charge. It also plus Q. Then we can obtain forces on this one. There is a repulsion due to this charge. Same charges, repulsion. There is an attraction due to this charge. Then its resultant force should be in this direction. There are same magnitudes for these forces because of there are same charges and same distance for the initial situation. But when trying to move in this direction, this charge is moving away from this one. As a result of it, this force is decreasing. Therefore, the charge is trying to move in this direction and finally it will attract to this one. Then moving path is like this one. We can obtain C is the correct path. Then answer is C. A solid conducting sphere of radius 2r contains a cavity of radius r, capital R, inside it. As shown in the figure, the sphere carries a net charge of plus Q. Another point charge of plus Q placed at the center of the sphere. Which of the following graphs best represents the variation of electric field intensity with the radial distance from the center of a sphere? We have to consider the charge distribution. There is a plus Q charge at the center. Therefore, there is a minus Q charge induced in this inner surface, minus Q. As a result of that induction, there is an opposite charge plus Q charge in outer surface. But there is a given plus Q charge for the outer surface. You know that charge is spreading on the outer surface for a conductor. Then, when considering this part, there is a charge in the center. Therefore, electric field will change like this. It is inversely proportional to R square. But there is no electric field in this region because of we know that there is no field lines for the conductor, in the conductor. But after passing this point, we can get that total charge, net charge inside this Gaussian surface is plus Q and minus Q cancelling. There are two plus Q charges. Therefore, it should be greater than this electric field and it will change by the same way. Therefore, we can obtain that first one is the correct answer. As shown in the figure, 2 point charges x and y are fixed along a straight line. The charge of x is positive. When the negative point charge is placed at point P, it remains stationary. What is the charge of y? Neglect the all forces acting on charges. Then we can get there is a positive charge at point x and a minus charge has been placed at this place. I will consider it as minus capital Q. We have to find charge at this place. Now I will consider charge at this place is Q. We have to find this, I will consider this charge as minus 1. It is easy to calculate. We have to find capital Q value. This distance is given as x and this distance is root 2x. We have to consider that there is no net force on this charge. And we know that there is an attraction due to positive. Therefore, it should be an attraction in this direction. Therefore, this charge should be plus. Now we have obtained mark of this charge should be plus. When finding magnitude, we can get that force on minus 1 charge in this direction should be equal to the force on minus 1 charge in opposite direction. Resultant force should be 0. We can substitute force as 1 over 4 pi epsilon Q into 1, this charge into this charge, divided by square of distance, x square. It should be equal to 1 over 4 pi epsilon product of charges 1 into capital Q divided by square of this one 2x square. Square of root 2 is 2. Then we can cancel out 1 over 4 pi epsilon and x square. We can obtain capital Q should be 2 simple q. It is plus 2q. Then answer is 5. Three identical conducting spheres A, B and C are mounted on insulating supports and separated as shown in the figure. Sphere A is given a charge plus 3q, C is given minus 2q. The sphere B does not have a net charge. Then sphere B is first touched to the sphere C. Next sphere B is touched to sphere A. And finally spheres brought back to the initial position. The remaining final charge in each sphere is given by A, B, C. A has a plus 3q charge. C has a minus 2q charge. They have given sphere B is first touched to C. B is touched to C. Then we know that charge will flow from high potential to low potential. And finally, potential will be same. We know that potential of a sphere is depending on its charge and radius. Radius means size. Now there are identical spheres. Then this charge is spread equally. Minus q and minus q. Then they have given next sphere B touch sphere A. Then touching B and A. Again, this net charge will spread equally. Plus 3q minus q means resultant charge, net charge plus 2q. Then charge of this one should be plus 1q and plus 1q. This charge is not changing, it is minus q. Then final charge plus q minus q. Correct answer is this one.